Hi, welcome to this part of the supervised classification lecture. Probably this is the next supervised classification, which is SVM. What it means is that support vector machine, another family of supervised machine learning algorithm. I'll explain that in a bit. So first thing first, some housekeeping. Make sure that you import the Earth Engine and FoliumG Hydro package and initialize Earth Engine. If it's your first time, you need to install and authenticate Earth Engine, but I'm assuming that you have already done that in the previous lectures. And the next important thing is just to import Folium to display our map result later. So this is the most important part of our lecture here. So here we'll implement SVM support vector machine, a machine learning algorithm on Earth Engine Python API. So the first thing is to import a Landsat data, a Landsat image collection, in this case Landsat 8 here. And the next thing I'll do is, because this is a long time series and a global data, we need to filter it by some sort of temporal window. Okay, so in this case I'll use data only for 2018. Okay, so I'll call my Landsat 8 image collection here and filter it by date here, 2018 January to December, and create an image composite. So what this does is creates an image composite for this time period. Okay, and I'll also define the different bands that I'll be using in my SVM classification. Here are the different bands of my Landsat 8 imagery. The other thing is create some training data. So what we're doing is a forest and non-forest class. So we need to provide some data points here. So lat long information. So in this case, it's a rectangle. So these are already predetermined in a rectangle. So we have one rectangle for forest, and another rectangle again for our forest cover. And this is a third you would say, you can say a training polygon, a non-forest area, another polygon, forest polygon for a non-forest area. Okay, so technically it's a forest and a non-forest geometry already defined. Okay, so from this random or just individual rectangles, I'll create a feature collection. Okay, I'll create a feature collection. So for each of the the rectangles, I'll declare EE feature, I'll call that, and then class, I'll define the class as 0. That means if it's a non-forest, I'll give it a 0. If it's a forest, a non-forest, again, I'll give it a 0 class. And for the forest areas, if forest 1 and forest 2, I'll give it class number 1, which is forest is 1 and non-forest is 2. Okay, so using these rectangles, now I have created a sort of a training data for class 1 for forest and class 0 for non-forest. Okay, and the next thing is using this polygon. Using this polygon data, I will overlay my image, my Landsat image. Okay, so I'll overlay my Landsat image within this feature collection or polygon, my training data. So collection here, I'll use the polygon here, and property is class, as I've already defined. Spatial resolution is 30 meter. So this will generate a training data. What it means is that it will have the forest class, forest, non-forest, as well as the different Landsat band values for all of these bands using my image. Okay, the next thing is to actually initiate an SVM classifier, support vector machine classifier. Here in this case, EE classifier. So I'll define the kind of model, it's SVM, and I'll define kernel type, RBF, and gamma and cost. These are some of the SVM parameters. I'll use the default parameters, I'll not change it. And I have already built in my SVM model, okay? So what I need to do is just provide a training data to this model, okay? So use this training data to fit into my model. So classifier train, training, okay? So this is my classifier, that means the SVM classifier, and implement provide or ingest my training data. So this will technically train my already defined model or classifier. So finally, using this SVM classifier, I'll apply this model to my Landsat image so that I'll have a classified image based on SVM. This is classified, that means our model result, okay? So I'll display that classified map here and also the raw Landsat image over here. So let's execute this entire chunk of the script. So it sounds like it's executed, and let's display our SVM classification result for a forest and non-forest class. So as you can see here, you can see, all right, let's just, okay. So this is deforestation classification. You can see this is a forest area and this is deforested area. If you look at our classification model, it's exactly matching this, yellow area, yellowish area is deforested area, and our classification is really getting it right. And this is the forested area, so our classification is classifying it green, which makes sense. We can also, so these are our training data points here, our training layers here that we have used for the different forest and non-forest class that we have used in earlier. So technically this is how you would implement a supervised classification, in this case SVM, support vector machine on Earth Engine using a Python API.